So that is stochastic gradient descent. And until the models covered until here, we'll be showing a demo for those. And these are some other models which can be used, but they need a large amount of data to be proper. So uh, this is k nearest neighbors, where you take you decide on k centroids and group them based on those. So here the number k is very crucial. So these kind of aspects uh, are important for k nearest neighbors. And then there's decision trees, and then so this is the for decision trees, you have the features as inner parts of the tree, and then decisions on the outside. So yeah, so when you have a random forest is nothing but a collection of decision trees, and you do predictions on each, and then vote uh, to what the outcome is. It's like an ensemble of decision trees. So we're going to focus on these four algorithms in our project. So pre-processing of data. So an example of tokenizing. Uh, so we do tokenizing of data first. Then this is the process of tokenizing, where you take a line and break it up into different uh, words, and you have from these words we select the features. So while creating our bag of words, what we do is we remove the stop words, which doesn't to the add or enhance the meaning, like the words like or, while, him, more. Like they're not going to change it much. So what we are trying to focus here is the adjectives. So we use parts of speech tagging functionality of analytical library to realize this. So I'll show you that in the code. And while selecting features in these bag of words, we use top 5,000 in our case, top 5,000 features. Uh, according to frequency. So I'll show you the code now. So these are the libraries imported, and this is we're trying to use the uh, adjectives. So we're filtering that out. So we have two functions here. This create tuples is more about cleaning the reviews. We feed the reviews and then it is cleaned up. So since the data is a movie review from movie review data set from IMDb, so we will clean it and then use it, and then we prepare the features. So after we create the features, uh, we take the first 20,000 for training, and then next 5,000 for testing. So here we have after training, we got the most informative features here, where here n is nothing but negative and p is positive. So it creates these likelihood ratios where it is when this certain word is there, there's a likelihood of it being a negative. So unpretentious. So these are some negative words maybe. So flawless, generally we use it for, you know, um, like praising the movie or whatever. So we have run the classification here, and then so for all the models I have mentioned, and then we have got the accuracy scores and F1 scores. So for accuracy score, so these are the accuracy scores we have got, and also we have a live sentiment analysis here. So for it's a great movie, it says positive, and this is the below. This is something I have got from IMDb website. So Yeah. So if you run this, okay, so you can clearly see it's not something positive. So this is a small demo on the live text and analysis. So coming back to the presentation. So as we have seen, uh, precision is uh, like how many actually true positives we have got among all the positives we have. That is like if we know there are more false positives, then we'll understand it's a mistake. And then similarly, there's recall accuracy in F1 score. So these are some measures which will tell us if it is going good or not. So coming to the results, we can see the original naive Bayes, um like the flavors of naive Bayes are doing well. So we have a real compute advantage over there. And coming to support vector machines, that classification is lagging behind. That might be due to less data or high dimensionality when compared to the data, since we have 5,000 features. So that is a lagging point, and SGD and logistic regression are close. So what more work can we do? So try different classifiers like random forest and KNN. For that, we need a lot of data and try different pre-processing like ngram pre-processing where you take 2 3 words at a time train and then you take an ensemble of 2 words and 3 words. So and also we can take ensemble of classifiers, use 2 3 different classifiers and vote to see which one wins. So what have we learned? So we have learned good amount of basic stuff to make such machine learning projects, which I've never done. So, and also we have come to know the domain knowledge is very important. So, yeah, and also we have known how to evaluate between different classifiers. Thank you.